Welcome to Investigating the Universe, where we delve deep into the fascinating world of technology and science. Today, we're journeying into the mysterious world of quantum cryptography. Now, you might be wondering, what on earth is quantum cryptography? Well, let's unravel that mystery right now. Quantum cryptography, in its simplest form, is a method of secure communication that uses the principles of quantum mechanics. It's like sending a secret message, but with an added layer of quantum security that makes it nearly impossible for anyone else to sneak a peek. To understand quantum cryptography, it's important to first understand its classical counterpart. Classical cryptography, the kind we use in our everyday digital lives, relies on complex mathematical algorithms. These algorithms create a kind of digital lock and key, securing our information as it travels across the internet. But with enough time and computational power, these locks can be picked and our information can be stolen. This is where quantum cryptography steps in. Instead of mathematical puzzles, quantum cryptography uses the principles of quantum mechanics, the science that describes how the tiniest particles in our universe behave. It's like replacing a traditional lock and key with a lock that's governed by the laws of quantum physics. Imagine trying to pick a lock that changes its shape every time you touch it. That's the kind of security quantum cryptography offers. It's based on the quantum principle that observing a system changes the system. In other words, if a sneaky eavesdropper tries to intercept a quantum encrypted message, the very act of observing the message changes it, alerting the sender and receiver to the intrusion. Quantum cryptography sounds complex, but fear not, we'll unravel the mystery together. To understand quantum cryptography, we first need to understand its backbone, quantum mechanics. Quantum mechanics is the scientific study of the smallest particles in the universe, like atoms and photons, and the strange, often counterintuitive ways they behave. Two fundamental principles of quantum mechanics are superposition and entanglement, and they are particularly relevant to quantum cryptography. Let's break them down. Superposition is a peculiar principle that allows quantum particles to exist in multiple states at once. Imagine flipping a coin. In our daily life, the coin can either be heads or tails. But in the quantum world, it's as if the coin is both heads and tails at the same time, until we check it. It's like Schrödinger's cat, both alive and dead, until you open the box to see. This principle is what makes quantum cryptography incredibly secure. It ensures that any attempt to eavesdrop or tamper with a quantum communication would immediately change the state of the quantum particles, thus revealing the intrusion. The second principle, entanglement, is equally bizarre. It's a phenomenon where two quantum particles become intrinsically linked, no matter how far apart they are. If you change the state of one particle, the other changes instantaneously. This spooky action at a distance, as Einstein called it, allows for secure communication over long distances. These principles might sound like they're straight out of a science fiction novel, but they're real, and they're the reason why quantum cryptography is considered uncrackable. Any attempt to intercept a quantum communication will change the state of the quantum particles and alert the communicating parties. But it's not just about security. The principles of quantum mechanics could revolutionize the way we transfer and store information, pushing the boundaries of what's possible in the realm of technology and communication. Quantum mechanics may seem like an abstract concept, but it's the key to understanding quantum cryptography. Now that we have a grasp on quantum mechanics, let's dive into a key application of quantum cryptography: quantum key distribution. Quantum key distribution, often abbreviated as QKD, is a method that uses the principles of quantum mechanics to generate and distribute a secret key between two parties. This key can then be used to encrypt and decrypt messages, ensuring secure communication. But how does it work, you ask? Well, it's all about leveraging the unique properties of quantum particles. In QKD, information is encoded into quantum states of particles like photons, which are then sent from one party to another. The recipient measures these particles to obtain the secret key. Now, if an eavesdropper tries to intercept the key by measuring the quantum states of the particles, they would inevitably disturb these states due to a fundamental principle of quantum mechanics called the Heisenberg uncertainty principle. This disturbance can be detected, alerting the legitimate parties of the eavesdropping attempt. But the genius of quantum key distribution doesn't stop there. It also employs another quantum property called entanglement. When two quantum particles are entangled, the state of one particle instantly influences the state of the other, no matter the distance between them. This phenomenon allows for the creation of perfectly correlated random keys between two parties, making eavesdropping virtually impossible. The significance of QKD is massive. In a world where our lives are increasingly digitized and cyber threats are ever present, the need for secure communication is paramount. QKD provides a solution that is not only secure, but also future-proof. It offers security that is not based on computational complexity, like many modern encryption methods, but on the laws of physics themselves. This makes it immune to advances in computing power, including the arrival of quantum computers, which pose a threat to traditional encryption methods. Quantum key distribution is a powerful tool in securing communication, thanks to the principles of quantum mechanics. It's a fascinating application of quantum physics that is set to revolutionize the way we protect our digital communications. You might be wondering, where is quantum cryptography used in the real world? Well, it's not just a fascinating topic for science enthusiasts, but it is also a practical tool that is already being used and will continue to shape our future. Quantum cryptography is becoming an essential part of securing financial transactions. Banks and financial institutions are always on the hunt for the most secure methods to protect their clients' information, and quantum cryptography is proving to be a game changer. By using quantum key distribution, these institutions can ensure the absolute security of their data transmission, making eavesdropping virtually impossible. This means that your online banking and digital transactions could become even safer than they are today. But it's not just the financial sector that's benefiting from quantum cryptography. Governments worldwide are also harnessing its power to safeguard their most sensitive information. In an era where cyber threats are a real and present danger, quantum cryptography offers a new level of defense. It can protect national security data, intelligence communications, and other confidential information from falling into the wrong hands. And that's just the beginning. The potential applications of quantum cryptography are vast and varied. For instance, it could revolutionize the healthcare sector by ensuring the secure transmission of sensitive medical records. It could also play a crucial role in the Internet of Things, where billions of devices communicate with each other by providing robust security measures. All in all, quantum cryptography is not just a fascinating scientific theory, it is a practical tool that's finding its way into various sectors, helping to secure our data and communications like never before. So the next time you make an online transaction or send a confidential email, remember that quantum cryptography might be working behind the scenes to keep your information safe. Quantum cryptography is not just theory, it's being used in the world around us and shaping our future. Scene script. Quantum cryptography is a rapidly evolving field. Let's take a look at what the future might hold. As we move into the future, quantum cryptography is set to revolutionize the world of secure communication. It's a field that's growing at an exponential pace, and with good reason. The potential is staggering. Imagine a world where your personal data is so secure that even the most advanced supercomputers can't crack the code. That's the promise of quantum cryptography. But what does the future of quantum cryptography actually look like? Well, it's a world where quantum key distribution becomes commonplace, where quantum networks span the globe, and where quantum secure communication is the norm, not the exception. Potential breakthroughs on the horizon include the development of quantum internet, which could offer unprecedented levels of security and privacy. This would be a game changer in a world where data breaches and cyber attacks are becoming increasingly common. However, this brave new world of quantum cryptography isn't without its challenges. There are still many technical hurdles to overcome. We need to figure out how to store quantum keys safely and how to transmit them over long distances without error. There's also the issue of quantum computers themselves. They're still in their infancy, and it'll be a while before they're ready for widespread use. But despite these challenges, the future of quantum cryptography is bright. It's a field that's set to redefine what we think of as secure. The future of quantum cryptography is exciting and full of potential. We've journeyed through the intriguing world of quantum cryptography together. From the enigmatic principles of quantum mechanics to the practical applications of quantum key distribution, we've glimpsed the future of this fascinating field, imagining a world where our most sensitive information is secured by the laws of physics themselves. As we continue to unravel the mysteries of the universe, remember to question, to ponder, and to wonder. Thank you for joining us in investigating the universe. If you found this video enlightening, please subscribe to our channel and share this video with others. Stay curious and keep exploring.